Okay, in 2.3 we are going to talk about graphing lines, and these are things that, again, you've done in Algebra 1, but it's worth reviewing now that we're in Algebra 2 since Algebra 1 was a few years ago. Some of your classes talked about graphing lines in slope-intercept form the other day when we were after 2.2, but some of you did not, so it's worth talking about. Slope-intercept form, remember, is y equals mx plus b, m being the slope, b being the y-intercept. Those are two very important things to know, and we can use those to graph lines very quickly, much faster than creating those xy tables that some of you really like. It's still okay to do that, but this would be a faster method. So here in our example, we're going to use the intercept, the y-intercept that is, as a place to start. So in our example, y equals 1/3 x minus 4, our -4 is the y-intercept. And the slope tells you where to go after that, so our slope is 1/3. And remember, slope is rise over run, so that will tell us where we go from that starting point. So with a y-intercept of -4 and a slope of 1/3, I'm going to start at -4 on the y-axis because it's a y-intercept. I'm going to label my scale here, and then rise over run tells me to rise 1 and run 3. So I'm going to go up 1 and write 1, 2, 3 and sketch that line in there as straight as I possibly can. Okay, and I get the line. Could we still make an XY table? Sure. Would it take a little bit longer? Yes. Graphing in slope-intercept form makes life a little bit easier, so I urge you to use that. Okay, let's try graphing this one. A -2x plus 4. So first identify slope, identify y-intercept. So what's the slope? Yeah, -2. And what's the y-intercept? Absolutely, 4. So I want to think of put my y-intercept on the graph, so I go up 1, 2, 3, 4. And again, I'm going to label my scale. I'm going to go from 5 to 5. My slope, though, I'm going to think of it as a -2 over 1, because then I have rise over run. So if I'm going to rise -2, that's like going down 2 and then run to the right 1. And again, sketch a line as straight as possible, hitting your dots on the way by. Okay? How do you feel about that? Another way we can graph is from standard form using the x-intercept and the y-intercept. So a review of what an intercept is: x-intercept, notice here, y is always 0. It's where it crosses the x-axis, so the y value would have to be 0. And in the y-intercept, x is 0. So pretty easy to plug in 0 for one or the other and get the intercept, and then you connect two intercepts and you graph. So here's our example. Let's find the x-intercept of 6x plus 4y equals 12. X-intercept means y is 0. So I think of just taking that 4y out of the equation, which means I have 6x equals 12. And if 6x equals 12, that means x is 2. To find the y-intercept, very simple. I take the x out of the equation, and I have 4y equals 12. And then I would solve, and I would get y is equal to 3. So I have intercepts there. And notice they are ordered pairs. I can plot these 2 points. So 2, 0, label my scale, and 0, 3. And then I connect the dots with as straight a line as I can draw, and I have my line graphed, or my equation graphed. Okay, so if you're given an equation in slope-intercept form, use your y-intercept as your starting point, and your slope tells you where to go. If you have a standard form, which was up here, ax plus by equals c, then I would suggest using intercepts. You could also solve for y, but intercepts are pretty easy to use as well. Okay, let's check out this example that was hiding. Okay, see if you can find the x and the y intercept here. Pause the video and see if your answers match mine. So x-intercept takes y out of the equation, so I would be solving 5x equals negative 15. When you solve that, x is negative 3. Y-intercept takes x out of the equation, so I would have negative 3y equals negative 15, and y would be a positive 5. So I'm going to plot my y-intercept up there, label it, and I'm going to label that as well. And then negative 3 on the x-axis, and oops, sorry about that. And sketch in my line as straight as I can freehand it. All right. Did you get the same thing I did? Good. Okay, two very special lines that we just kind of want to memorize what they look like. A vertical line always is x equals a. Horizontal lines are always y equals b, so those are two things we kind of just want to know forever. Would be great. So our example here in red, x equals 3. So points on the line, we can have 3, 0. We could have 3, 4. We could have 3, 17,000. A negative 2. Anything, y can be anything. Our only equation or stipulation is that x has to be 3. So if I plot all of those points, there's 3, 0. There's 3, 4. And here's 3, negative 2. So you see that all of those points are on a line that is vertical. Okay, so x equals vertical line always. So now in this one, horizontal lines in blue, y equals some number b. The only thing we know is that our y value has to be negative 2 in this case. So x could be something like negative 1 or 0 or 3. Okay, y is negative 2. So let's plot some of those points. Negative 1, negative 2, 0, negative 2, 3, negative 2. And they all line up on this horizontal line that I drew in blue. So if you can remember that y equals is a horizontal line and x equals is a vertical line, you'll be in pretty good shape. Okay? That's pretty much all you need to know about graphing lines for this section. Do your best to graph as accurately as possible. You can find graph paper online. You probably have some at home, something like that, just to try and make your graphs as accurate as possible. For the word problems later in your assignment, it says simple sketches, so then you wouldn't need graph paper necessarily. Just do your best to make some really neat and accurate graphs. All right? If you have any questions, let your teacher know.